larger value, right?
Mm-hmm.
So that will make the delta y unnecessarily large. Can we draw a picture? Can I draw a picture?
So if we plug in 5.1 and 5 minus 5.1.
Well, that won't change it. That won't change anything. Because 5 minus 5.1 is just negative.
Yeah, but I think theoretically it should work. Because it is the difference.
What's the difference? The 5.1 that's right?
Yeah,
no, the 5, but that's not a difference, right? That's an exact location.
Mm-hmm.
That's not a difference, though. One and the derivative is not a difference.
So this and this is a difference.
Right.
So 5.1 and 5 is a difference. So you should get a two right ends answer. I don't know how. So it is a delta x and delta y is a difference. So if you get two number 5 and 5.1. So one should be the delta x is always 0.1.
Yeah, delta x is always 0.1. That's true. That's true. Whether this thing increases or decreases, it's 0.1 difference for that. That's true. But where are you starting? If you're decreasing, if you were decreasing, you'll start at 5.1, and then you would use 5.1 inside here, and this difference would be
minus
5 minus 5.1 if we make it negative, which would show you had a decreasing change. You had a negative change.
But it says from 5 to
5.1. So yeah. So 5 goes in the original because you're taking. You have this sphere, and it's got a radius of 5, right? And you want to know how it's changing right at that moment. Not how it's changing at 5.1. You want to know how it's changing right at that moment. No? If you draw the picture of this, right, like the cubic function, just forget it as forget the fourth order pi. Just make the cubic function. Right? Okay. So you're taking its derivative, and you're putting in the number 5. That gives you a certain slope, right? Starting at 5, and you're working and you're finding what's the change here, right? There's your slope, right? And it's underneath the curve. There's your cubic, and here's your thing, right at 5, right? Out of that. Okay. So you're trying to find how far did this change here? What's that change? From the 5 on the tangent line to the 5.1 on the tangent line. That's what you're finding. If you put in the 5.1, then you're taking the slope higher up. Yeah? Does that make sense? And then the change is going to appear higher. That, so what was the function?
Alright, so derivative x equals
F5.
5x plus 2 sine pi x. And then we have f2 equals 3. Yep. So now it says find a particle function.
Particle function?
Yep. Of that.
Meaning this is the velocity you're saying, or something. Position function? Particle or position?
Particular function.
Oh, particular. Okay, gotcha. Okay, so
satisfy the given initial condition, which is that.
that's right. Yeah, that's right. Okay, so there's our initial condition. Okay. So you know that you're just trying to work backwards to the original function, right?
Yeah.
So what do you take the derivative of to get 5x?
5x squared.
Correct. So if it were just 5x was worked with the way you're thinking, if it were 5x squared,
Yeah.
then you took the derivative, you'd get 10x and not 5x.
But
So
divided
you-
by 2.
Right, so you cut it in half. All right, you cut it in half.
Yep. And we have minus
Okay, hold on a second though. So what do you take the derivative of to get sine?
cosine.
Okay, so this has something to do with cosine. And the input should stay the same. Should be cosine pi x.
Yep.
Okay. So if I take the derivative of cosine, I would get negative sine. And wait a second, it's positive, so therefore I need the negative, right?
Yep,
That's what you're saying?
negative 2.
Okay, and the 2 is just a multiplicative constant, so it stays the same.
Yep.
And now, if I take the derivative of this, it would give me negative 2 sine pi on x, but then I would take the derivative of the inside and give me pi on the outside.
Divided by pi.
So I got to divide by pi to get rid of x. I don't see it up here, right?
Yeah, yeah.
Okay. Right. And then you put plus c, because you can add any constant you want, and it'll still be the same derivative.
Yeah.
Right?
So then we start out with 3 equals 5x
replace
squared
3
divided by 2.
So 5, 2 squared divided by 2 minus 2 cos. I'm going to write 2 pi just so it's a little clear. Over pi.
Plus c.
And the whole point now is just determine the c, right?
Yep. So we flip it over and we get
Hold on, what's the cost of 2 pi?
0.
No, not 0.
Oh wait.
It's 1, right?
So what's
Sine,
1?
sine of 2 pi is 0.
Okay.
Cost of 2 pi is 1.
Yeah, that's 1.
Okay? So we get minus 2 on pi here.
Yeah, yeah.
So we have
So you have 3 minus 10 minus 2 pi. 2 over pi.
Okay. But this
Equals-
will be plus, right?
Yeah.
So we move it over there.
Equals c.
Right. So that's negative 7
Yep, negative 7
plus 2 on pi.
So therefore,
So that's our c. So now we just plug it back in up here. Now they may want it as a fraction. I don't know. If they do, this would be negative 7 pi plus 2 on pi. That's how we write the c then. They needed it expressed as a single fraction. And yeah, just append that up here in the place of this, write the function and then that expression. That's right.
so it'd be like that, and then we have minus 7 pi plus 2 divided by pi
Yeah.
is equals fx. And then I was asking like graph several functions that satisfy the given differential equation.
Graph several functions.
Yeah, that satisfy the given differential equation.
What's the differential equation? The original up here?
Yeah, yeah.
Okay. So if you ignore the initial condition,
Like earlier when I tried to graph it, it didn't came out like the way they showed it right here. So here I start with this, right?
5x plus 2. No.
No?
Hold on a second. Let me look what they got there. Graph the particular function satisfied.
Well, before we get this.
Oh, sorry. That's graph several functions that satisfy the
Yeah.
given differential equation.
And when I plug these in, which they told me to, right? And when I get
No, you don't want that.
no
Graph the thing that has the plus c on it.
plus
The thing that has the plus c. Graph f of x, not f prime. Graph f of x.
right,
But don't put the plus c on there. Just write 5x squared on 2 minus 2 cos pi x on pi. Put that in the calculator. 5x squared here.
5x squared.
Yeah. On pi, not on 2.
Huh?
That one there is on 2. You want on pi.
Yeah.